SpaceX has just dropped a breakthrough update, and it changes everything we thought we knew about Starship. After months of silent development and cryptic hints from Elon Musk, the company has finally revealed its next-generation heat shield, a design so advanced it could rewrite the blueprint for interplanetary travel. This isn't just a few tiles or minor fixes, this is a full system overhaul, a radical upgrade engineered to survive the most violent re-entry conditions ever attempted by a human-made spacecraft. And if it works, it could be the key that unlocks Starship's future on the Moon, Mars, and far beyond. Today, we're breaking down what SpaceX just revealed, how this new-gen heat shield works, and why experts say this upgrade might be the biggest leap forward since Starship's first flight. Stick with me, because what you're about to see has changed everything. With the debut of the version 3 design on Ship 39, SpaceX appears to have introduced major upgrades intended to eliminate those weaknesses and open the door to more capable missions ahead. So how has SpaceX improved the Starship version 3 heat shield? In this upgrade cycle, the vehicle itself naturally becomes the focus. And the Starship upper stage will take center stage because it is the part that revealed the most issues in earlier versions, despite achieving meaningful milestones. The same applies to ships as well. Ship 39, the Block 3 upper stage, sitting nearby, is getting ready for cryo tests. Ship 39 has already gone through its early build stage checks, but it hasn't run a full cryogenic proof test yet, but all the ground hookups and lines are already set up for it. The ship is basically in the ready for cryo position, waiting for SpaceX to schedule the test. It also doesn't have its Raptor 3 engines installed yet, which is normal for this stage. SpaceX usually completes cryogenic testing before mounting the engines. Block 3 ships like Ship 39 are built from the start to work with the newest Raptor 3 engines. And this engine is a major jump from the older Raptor 2. The biggest difference is how much simpler the new engine is. SpaceX rebuilt it in a way that removes a lot of the complicated plumbing and delicate parts that used to make Raptor 2 harder to manufacture and maintain. These engine upgrades are the reason Block 3 ships like Ship 39 look different from earlier models. However, beyond that major system, there is another area that has undergone a dramatic transformation. That system is the heat shield. The clues were visible weeks before Ship 39 was fully stacked. As its various sections were rolled toward Mega Bay 2, the heat shield tiles appeared noticeably different from previous vehicles. Observers who followed each rollout noticed how clean, uniform, and tightly arranged the tiles appeared. The gaps looked significantly reduced, the surfaces were smooth, and the bonding material between tiles appeared more solid and consistent. The same pattern held true across every section that arrived at the bay, and once Ship 39 was fully stacked, the improvement became even clearer. The entire heat shield looked unified and polished, inspiring confidence. This upgrade is especially meaningful given the challenges SpaceX faced with the version 2 heat shield. In the last 2 Starship flights, which were both major successes, the vehicles managed to push past the most problematic stages of re-entry and survive long enough to complete their missions. Yet, after those flights, we saw the unmistakable signs of stress. Large areas of the heat shield were streaked with white and orange. The white streaks indicated coolant leaks, likely caused by extreme heat entering the gaps between tiles or between the tiles and the structure beneath them. The orange streaks pointed to oxidation, formed when coolant interacted with the metallic test tiles installed on parts of the version 2 vehicle. Together, these issues highlighted the vulnerabilities that still had to be addressed, especially in a version that was meant primarily for testing. Now the expectations for version 3 are very different. This version needs to succeed at specific mission-critical tasks that leave very little room for error. That is why the heat shield redesign is so important. The first major upgrade is completeness. Ship 39 appears to carry a full uninterrupted tile set. While a few areas seem to show missing tiles, these are very likely spots where installation simply has not been completed. For the first time, it looks like we will see a fully realized heat shield that reflects the final intended design. This allows SpaceX to evaluate the entire system at full performance and identify any issues that still need refinement. The second upgrade is the tile design itself. Musk previously stated that the version 3 generation would incorporate a completely redesigned structure, and that redesign includes the heat shield tiles. SpaceX may have adjusted the tile compositions, strengthened the material, or added new elements to reduce cracking and prevent damage during the highest heating periods of re-entry. Attachment methods also appear improved. Tile loss was a risk factor in earlier flights, especially when extreme vibrations and heating occurred simultaneously. The new mounting design likely aims to secure the tiles more firmly while also allowing for controlled expansion under heat. While that approach showed promising results, it was not perfect. The version 3 will almost certainly use an evolved version that seals these gaps more effectively while still allowing for the flexibility needed during the extreme temperature swings. One of the clearest visual upgrades is the improved bonding at tile corners. When looking closely at Ship 39's tile layout, you can see small white filler points at spots where 3 tiles meet. These appear to be reinforced bonding materials designed to eliminate microgaps that previously allowed heat to penetrate into the underlying cooling structure. These tiny improvements collectively represent a major leap in reliability. All of this sets expectations sky high for the first version 3 flight. Ship 39's heat shield is not just an upgraded component, it represents the next major step toward a fully reusable, fully reliable Starship. And that future is approaching quickly. With Ship 39 now fully stacked, its production phase is essentially complete. The next steps are critical. The vehicle will undergo cryogenic testing, exposing the heat shield and structure to extremely low temperatures to ensure that the tiles remain attached and stable. After that comes the static fire test, which will subject the vehicle to extreme heating and vibration. These stages may begin as early as late this month and continue into the next. Then comes the true test. They, now aiming for a January launch, will put the version 3 heat shield through the full force of atmospheric re-entry. It'll face temperatures, pressure, and aerodynamic forces far beyond any ground test. The long-term importance of the Starship heat shield extends far beyond a single test flight. It's the foundation that allows the Starship upstage to return safely, and it is the key to achieving the level of full rocket recovery that SpaceX has envisioned from the beginning. This recovery approach is not simply about splashing down in the ocean, it's about bringing Starship back intact so that it can be caught, returned to the rotation and prepared for its next mission with maximum efficiency. This is the core of SpaceX's plan for a truly repeatable, truly economical launch system. Reaching that milestone will set Starship apart from every other launch vehicle in development today. Many companies still rely on expendable rockets either because reducing cost is not their primary focus or because they do not yet have the technological capability to build a fully reusable system. True reuse depends on how well heat shield protection performs during vehicle re-entry. The tiles must keep Starship in good enough condition that the refurbishment process becomes quick and straightforward. If the heat shield performs perfectly, Starship can be inspected, repaired, and prepared for another launch in a remarkably short amount of time. This is why upgrades to the heat shield system are so critical. Even if SpaceX successfully catches the vehicle, replacing every tile after each mission would defeat the purpose of full reusability. Solving these problems is essential for Starship's long-term operational rhythm. In short, the heat shield is not just another component, it's a central factor that will determine how quickly, how reliably, and how affordably Starship can fly again and again. It'll influence many flights and many vehicles in the years ahead. For the next test flight, catching the vehicle will be a major milestone, but the performance of the heat shield will be equally important for proving that full and rapid reuse is within reach. Looking further into the future, it's clear that the Starship heat shield still has enormous potential for improvement. This is the reason Musk continues to describe the heat shield as one of the 2 major remaining challenges that SpaceX must overcome in order to achieve sustained multi-planetary operations. The most immediate challenge is the sheer scale of the heat shield. Managing such a massive system introduces difficulties at every stage. To manage a system of the size, SpaceX will need strategies that reduce issues at the earliest possible stages. Another significant challenge is the complexity beneath each tile. The heat shield system is not only a layer of protective plates. Depending on the design, there may be a blade of layers, active cooling systems, or the newer crunch wrap concepts. Integrated underneath. When each tile contains multiple components, the entire system becomes more complicated to build, inspect, and repair. Simplifying these substructures, or integrating them into a more unified design, will be essential for long-term operational efficiency. A heat shield that is easier to assemble is also one that is easier to reuse, which is the ultimate goal. These two challenges, being scaling the system and simplifying its internal structure, are the most pressing issues SpaceX must address. Still, there may be other concerns that emerge as the program advances. We are now approaching a Starship version filled with promise. Throughout this year, both the booster and the ship have received continual upgrades. And the new heat shield stands out as the defining feature that will move Starship closer to rapid and complete reuse. As Starship version 3 begins its flight campaign next year, pay close attention not only to its orbital maneuvers, payload operations, and two-stage landing efforts, but also to the performance of its protective armor. And as SpaceX pushes Starship into a new era of engineering, one thing becomes clearer with every upgrade: we are watching the birth of the spacecraft that could change humanity's future forever. This new-gen heat shield isn't just a technical improvement, it's a declaration that SpaceX is moving faster, aiming higher, and preparing for missions no one has ever attempted. If you enjoyed this deep dive into Starship's newest breakthrough, make sure to like, subscribe, and hit that notification bell so you don't miss the next update, because if this upgrade is any sign, the next reveal could be even bigger. Thanks for watching, stay curious, and as always, we'll see you in the next one. And that's about it for today's episode. Thank you so much for tuning in, and that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to my channel and hit the like button. And if you want to support our channel and if you want to be up to date, you can become an exclusive member, so click on our perks through the link in the description below. Thanks to watching and see you next time.